Sunspots AR 3697 and AR 3664 are again in front of Earth and are sending huge streams of plasma towards us. When these solar flares hit our Earth, intense geomagnetic storms occur, scientists warn. May 2024 saw the strongest solar storms in over 20 years, and now the intensity is increasing again. The expected peak of the current solar cycle could send us the strongest solar storm ever. Did you see light shows over Europe in May 2024? In some places, the night sky was blood red, while in others there were green or blue auroras. These spectacular auroras, usually seen only in the outermost polar regions of the Earth, were triggered by a massive solar storm. In the northern hemisphere, the light spread far to the south, and in the southern hemisphere, the play of colors could be seen far in the north. The entire Earth was affected by the particle flow so strongly that the safety mechanisms of our Earth's magnetic field failed. Electromagnetically charged particles penetrated the deep atmosphere and gave us more than just a mesmerizing glow. This time we were lucky. After the biggest storm of 2011, few regional power providers reported problems or outages in the power grids. Elon Musk was relieved to post a chart showing how well his satellites weathered the storm. This scenario could have gone very differently. A solar storm the size of May could have sent us into a global crisis. Now the huge sunspots responsible for the storms are reappearing. What's going on AR 3664 shows alarming activity on the surface of the sun. Who would have thought that an X-flag of devastating proportions could be completed in a matter of weeks? Scientists carefully watched the events of the sun, and even amateur astronomers could almost see the incredible with the naked eye. Over the course of a few days, several smaller sunspots merged to form a huge sunspot 15 times the size of our Earth. On May 9, 2024, NOAA's GOES-16 satellite observed a solar flare at 10 p.m. A huge stream of particles separated from the surface of the sun and headed towards us. The source of the storm was clearly sunspot AR 3664. Soon after, security systems issued a G4 geomagnetic storm warning. A G4 storm is classified as severe on NOAA's geomagnetic storm scale, and at worst, such a storm will bring us power grid and satellite technology outages, disruptions to navigational systems and near-polar air traffic, and additional disruptions to magnetic or electrical systems. The storm had just hit Earth when AR 3664 released a new particle stream on May 10, 2024. Satellites recorded a powerful X5.8 class solar flare. The show started at 3:23 Central European Time, and the storm raged over the weekend, bringing us another spectacular aurora and several power supply issues. On May 11, 2024, geologists recorded a huge tension in the Earth's magnetic field. For the first time, charged particles from the sun interacted with the atmosphere so violently that regional weaknesses and holes were formed in the magnetic field. We do not yet know what the long-term effects of such disturbances will be on the Earth's magnetic field. We can only hope and pray that our Earth will withstand the stresses. No one knows exactly what might happen if our Earth's magnetic field fails. However, if permanent damage were to occur, we would certainly be exposed to an alarming increase in radiation. In a worst-case scenario, we could lose Earth's atmosphere, which could have similar long-term consequences on Mars. On May 14, 2024, a G5 storm hit. Scientists have seen this coming for many years. They warned of the day when the G5 storm will put our civilization to the severest test. On May 14, 2024, that time has arrived. The largest sunspot caused a Class X 8.7 solar eclipse, which immediately went down in history as the largest of the current solar cycle. Sunburn affected the G5 storm. These types of cells cause huge coronal explosions that throw even more particles to Earth. The aftermath of this solar event once again brought long-lasting geomagnetic storms to Earth. On May 27, 2024, it continued. Another powerful X-class solar flare was observed. This time, shortwave radio transmitters and receivers around the world failed. International radio broadcasting, emergency communication systems, marine and aviation radio, and military communication systems were affected. Ordinary people around the world were delighted to see the northern lights in places where this phenomenon is not usually seen. The last geomagnetic storm in May 2024 was shown to have affected the field deep into the ocean and had a measurable effect on deep-sea compass systems, disrupting submarine communications. International power companies reported regional problems with power line systems, and several satellites were disrupted by renewed violent solar storms. AR-3664 becomes AR-3697. What can we expect? Did you know that we can expect threatening emissions from the Sun 24/7? Hardly anyone on Earth is aware of this danger. Sunspots happen all the time, and they don't have to be as big as AR-3664 to cause us problems. Even smaller sunspots, which sometimes appear very quickly, can release huge rockets. Sunspots are formed due to strong magnetic activity on the surface of the Sun. The Sun consists of different layers, and basically the magnetic field is created inside the Sun. Magnetic fields are formed by the movement of electrically charged plasma within the Sun. As these magnetic fields penetrate the Sun's surface, they prevent hot plasma from rising from the interior, making the affected regions cooler and darker. It is about sunspots that we can see, according to their size, either with the naked eye, but protected from the Earth, or with suitable telescopes. Solar observatories like SOHO monitor the Sun around the clock. Any surface change is immediately reported and scientists continuously monitor the Sun's emissions. SOHO stands for Solar and Heliospheric Observatory, a stationary space probe launched jointly by the European Space Agency and NASA. Since December 1995, the satellite has been observing our Sun at a distance of about 1.5 million kilometers from Earth. SOHO is in a very similar orbit to the new James Webb Space Telescope. The largest solar observatory on Earth is located on the Haleakala volcano on the island of Maui in Hawaii. Solar observatories are significantly different from conventional telescopes because of the direct view of the Sun. They must work with special filter technologies and be protected from constant solar radiation. In April 2024, solar researchers in Hawaii and experts in charge of the SOHO facility observed the formation of AR-3664, a true giant among sunspots. At the peak of the solar cycle, it is normal for even larger and more interesting sunspots to appear. This time, however, everything is different. For the first time since 2003, AR-3664 bombarded Earth with solar storms so intense that a permanent warning was issued. After the first flash, this point once orbited a burning hot ball of fire along the axis of the Sun's rotation.
After a 27-day cycle, it returned. It then headed straight for Earth again, and scientists were alerted again. AR-3664 has changed as it orbits the Sun.ISA rocket, or a CME stronger. It is hard to believe that the Sun has regions that are up to 15 times the size of our Earth, and that these regions are cold and dark. Sunspots form during completely normal processes within the Sun. Gases, plasma, and particles bubble up in different onion-shaped layers. The magnetic field causes disturbances beyond our imagination. Millions of tons of boiling hot material suddenly rise, sink, bubble, or cool. When the magnetic field lines twist in the layers, a sunspot is created that is significantly darker and also cooler than all the other surrounding regions. Thanks to the cooling and an effect that scientists call magnetic reconnection, a huge amount of energy is suddenly released. This phenomenon is called solar flares or coronal mass ejections, CMEs for short. The difference between rockets and CMEs is the formation and amount of material released. Sunburns are caused by the rapid release of energy, light, and high-energy particles from twisted magnetic fields. CMEs, on the other hand, are huge bubbles of plasma and magnetic fields that are sent into space by the Sun's corona. When these bubbles hit the ground, they can cause geomagnetic storms such as flares, disrupt electrical systems, satellite and navigation systems, and cause intense aurora borealis. Missiles usually consist of less dense streams of particles, but they are faster and hit us within minutes or hours. CMEs carry more mass, but often take days to reach us. AR-3664 becomes AR-3697. It's not over yet. Sunspot AR-3664 might have decayed, But instead of fading, it changed shape and now shines like AR 3697. A regrown site can continue to cause significant damage to the Earth. When AR 3664 returned after 27 days of orbiting the Sun, it underwent a dramatic change. The site was reclassified as AR 3697 when it burned due to the chatter of many magnetic field lines. This is completely normal. Renaming after orbiting the Sun is a common practice and helps scientists continuously monitor and analyze these phenomena activity on the surface of the Sun. On June 1, 2024, an upgraded X4.7 class solar flare was launched at the site, aimed directly at Earth. The geomagnetic storm also caused technical problems in the maritime radio service. AR 3697 was still very active on June 6, 2024. When Earth was hit by a second lightning strike at 2:32 Central European Time, the G4 alert was automatically triggered again. That is the same magnitude as the first severe geomagnetic storm of the last solar cycle. This time, however, the consequences may be more serious because our magnetic field has weakened. So far, we have been lucky and AR 3697 is once again disappearing from our view momentarily. However, experts warn of even stronger solar storms in the future. The solar cycle should peak in 2025. If we are as lucky as May 2024, we will succeed. However, if our magnetic field is damaged, it could look very different in the coming years.